Hello. I just did in the last video, I just did a list of steps to follow for finding confidence intervals. We did an example. Now we're going to do another example. First, I have a series of different examples. Only the next couple ones are worked out. And then after that, we're just deciding, can you use a normal distribution, a t-distribution, or neither? Here's an example. It's from your textbook. Let's read it. The gas mileages in miles per gallon of 28 randomly selected sports cars are averaged. So we find the mean. We're not going to actually be able to work this out because we're not told the average, but let's see if this would be a normal distribution, a t-distribution, or neither. So what is our n? 28 randomly selected sports cars. Our n is 20. N equals 28. Notice that's less than 30. Then you would find the average of it. You'd get that sample to get your sample mean. But can we even do this problem for this? Assume the mileages are not normally distributed. So look at you don't have a normal distribution. You don't have a sample size bigger than 30. You would need a bigger sample size to be able to do either distribution for this one. So the answer for this one is you could do neither. Now this one we're actually going to decide which to do, and if we can do it at all, we're going to actually work it out. So I am grabbing a paper. You grab a paper. I'm going to jot down the important information, then I'll write it down, and we'll calculate it. So I've got my paper. I'm going to read the first sentence. You randomly select 25 newly constructed houses. That's n equals 25. That's my sample size. Now, I need this to be normally distributed to be able to do anything with it. So let's read the whole problem, then we'll come back and pick out the other information. The sample mean construction cost is $181,000. Actually, let's practice. What symbol should you use for that on your paper if you were working this out? Sample mean, X bar, equals 181,000. That's what I'm writing on my paper. X bar equals 181,000. And the population standard deviation is 28,000. So they're telling us the population, which is set sigma, is $28,000. So I'm writing that on my paper. Assuming construction costs are normally distributed, okay, we can do this. Even though our sample size is less than 25, we're assuming this. Should you use the normal distribution, the t-distribution, or neither to construct a 95% interval population? We're going to do a 95% confidence interval for the population mean construction cost. Explain our reasoning. Not only am I going to explain the reasoning, I'm going to work this out as another example. So we're given the population standard deviation. So we will use the standard normal distribution table. So actually let me go to my whiteboard and I'm going to work it out there. And so let's just write what we know so far. N equals 25. Sample mean equals 181,000. And then the population standard deviation is 28,000. So because I know that, I'm going to use a z distribution, and I'm going to want to find z sub c. Now just remember, this is also called your point estimate, which I'll be using later on to construct my interval. But if I ask you that question anywhere, it's not hard. It's the sample mean. Remember, we're predicting where the population mean is going to be. So to find z sub c, I'm going to go to my standard normal table. Hopefully I still have this up here. This is my t-distribution table. I go to my standard normal table and I go to this little thing at the very bottom, critical values. See where it says critical values? And I'm doing a confidence level of 0.95. So my critical value is z sub c is 1.96. So that's what that is for. So I'll go back to my whiteboard. 1.96. Okay. So next I'm going to find my margin of error. E equals z sub c times sigma over the square root of n, because we know sigma. Otherwise, you'd have to be using t and s. But anyway, 1.96 times 28,000 divided by the square root of n, the square root of 25, which actually, I'm going to grab my calculator. Actually, the square root of 25 is 5, so you could actually just put 5 there. Or if that doesn't work out evenly, you'd enter this in your calculator as 1.96 times 28,000 divided by the square root, enter the square root, 25 equals, and I get 10,976. This is my margin of error. Okay, so I've calculated my margin of error. So this is really important. You use your point estimate and your margin of error. I'm going to erase to make more room. Now I want to construct my confidence interval. A picture might be really helpful. You've got a number line. Okay, number line, 181,000 would be in the middle. First I'm going to find the right-hand endpoint. I'm going to just take, I saw my margin of error on my calculator, so I'm going to 10,976 is already on my calculator. I'm just going to hit plus, so I don't have to type that over again. 181,000, 000. I get 191,976 on the right-hand endpoint. And then I'm going to enter 181,000 minus minus 10,976 minus my E. Remember, this is the middle's X bar. This is X bar plus E, and this is X bar minus E. And so I just took 181,000 minus my 10,976, and I got 170,000. I'm having a hard time writing. I'll try again. I don't think my iPad's working over there. I'm going to write the final answer down here. What I got over there is 170,024. And when I got on the right-hand endpoint is 191,976, and I could write this is my confidence interval, meaning that I believe that my population mean is going to be in this interval between here and here on the number line, somewhere in there. So how do I state that as a I'm going to write those down. How do I actually write out the interpretate? That's my confidence interval. So that's the answer to the question if I asked you to construct a confidence interval. And now let's go back to the problem so we can state it in words. What does that mean? So back to my original, the problem I was working on. And I have to go back because it looked like, sorry. And there's probably a quicker way to go back that I haven't figured out yet. There we go. Okay. So, at a 95% level of confidence, so I'm going to just say it verbally instead of typing it out. At a 95% confidence, we can say that the mean construction cost is between the two values I just got, 170,024 and 191,976. So if you need to hear that again, you can rewind me. I think I have some tips on the next page. Because we knew we knew that it was normally distributed, that's how we could do it. This is just a review. We knew the population standard deviation, so therefore we're using Z values. We're using the standard normal table. And then I showed the work on the whiteboard. Okay, so what can we use here? Let's see. Can we even do it at all? Whoops. I've got the answer showing. Sorry about this. So again, I'm using my iPad and I don't usually. So, okay, here's the problem. In a random sample of 50 people, look at n is greater than 30, so we're good there. So we can do something. The mean body mass index was 27.7, and the standard deviation is 6.12. All right, we need to know normal distribution or t-distribution. Now look at the way, they should have also had like units here, which, anyway, we need to know if this standard deviation is a sample or the population. Now, notice the whole sentence talks about the sample. Like, in a random sample, 50 people, blah, 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 blah. That means this is the sample standard deviation, S equals 6.12. So if that is all they're giving us, and then they ask us to construct a confidence level at whatever percent confidence, we're only given the sample standard deviation. And its sample's not right here, but this whole sentence is about the sample. So this would be interpreted that that's S. So you would have to use a t-distribution to find your critical value. In fact, let's practice that. Remember, for the t-distribution, that's when you need the degrees of freedom, which is one less than this. Our degrees of freedom is 49. Oh, and we don't know which are, but you would go to the table, not this table, this is the z table. You go to the t-distribution. Is 49 on here? Nope. Notice how 49 is not on here. In a previous video, I told you that if your number's not on here, notice there's 45 degrees of freedom and 50 down here on the left. 49 is between there. It's not on here. You always go with the lower value. So we're going to use 45, and then we don't know what confidence level. You would use the 45 for that one. So, when I had said this once before, when your degrees of freedom isn't there and you're trying to find your critical value from the table, you would use the one that's lower to it. Always use the one that's lower. Okay, let's see what we're going to do here. In a recent season, the population standard deviation of yards per carry of all running backs was 1.80 yards. This is a football problem. The yards per carry of 13 randomly selected running backs is listed. Assume the yards per carry is normally distributed. So it's normally distributed, so we can do the problem. And in the problem, they'll give you information, more information. So in a recent season, the population standard deviation yards per carry, that's the population standard deviation, that's sigma. That means we're going to use a z table. We're going to use our z table based on, we're going to go to the standard normal table to get at the very bottom of that first page to get our critical values. Okay, so I'm just like talking about, I guess that's the end of all the examples that I have. So follow the steps that I had you show on the previous slide for constructing a confidence interval. And you have to decide, do I know the population standard deviation or can I only use a sample standard deviation?